Welcome to our course, this lecture, Generative AI for Leaders. In this session, we will explore the foundational concepts of machine learning, the driving force behind generative AI. Understanding these basics will provide you with the necessary knowledge to grasp more advanced AI topics later in the course. Machine learning is at the core of many AI applications, from predictive analytics to generative models. Today we will break down the essential elements of machine learning and discuss how it powers the AI systems we use today. So in this slide, introduction to machine learning. So what we see from the this introduction, like machine learning is a subset of artificial intelligence that enables systems to learn from data and improve over time without being explicitly programmed. Unlike traditional programming, with what we see in the left side, where rules are predefined, machine learning algorithms identify patterns in data and make decisions based on those patterns. For example, instead of manually coding every rule to recognize a cat in a photo, a machine learning model can learn to identify the cats by analyzing thousands of labeled images. So it can identify. So this, you can see the difference, what I mentioned. Types of machine learning. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Each type is used for different tasks depending on the nature of data and desired outcome. Let me explain each of them. Supervised learning. It involves training a model on level data where the correct output is known, and the model learns to map inputs to outputs, making predictions on new unseen data. So this is supervised learning model. Then the next is unsupervised model. Deals with unleveled data. The model tries to find hidden patterns or intrinsic structure within the data. Clustering is a common technique used in unsupervised learning. And next is reinforcement learning. Is a type of learning where actually an agent learns to make decisions by performing actions in an environment to maximize some notion of cumulative reward. So these types of learnings are applied to different tasks depending on the nature of the data and problems being solved. Key algorithms in machine learning. There are several key algorithms in the machine learning, each suited to different types of problem. Like the decision tree, these are used for classification and regression tasks, where the model splits the data into branches to make decisions, what I see here, also here. The next is support vector machines. So this is actually or it is called as SVMs, are powerful for classification tasks, especially when the data has clear margins of separation. Next is neural networks. So is the backbone of deep learning and are used for complex tasks such as image and speech recognition. Clustering algorithms like k-means are used to group data points into clusters based on their similarity. Next, we will discuss the role of data in machine learning. So data is foundation of machine learning. The quality and quantity of data directly impact the performance of machine learning models. Proper data pre-processing, such as cleaning, normalization, and feature engineering is crucial to building effective models. For example, in a generative AI model, the more diverse and high quality for the training data, the better the model will be at generating realistic and useful outputs. Training and testing in machine learning. Training a machine learning model involves feeding it data and adjusting its parameters based on the performance. The goal is to minimize the error between the model's predictions and actual outcomes. Once the model is trained, it's essential to test in on a new unseen data to evaluate the generation ability. This process of training and testing is key to developing robust AI systems that perform well in real-world applications. So here we see some diagram here, the high-level overview of machine learning process. They train the model and they test the model and finally they deploy the model. So these are the steps we are mentioning here, the processing of training and testing in a machine learning model. Applications of machine learning. Machine learning powers many applications across various industries like e-commerce. Recommendation systems support products based on customer behavior. Then in finance, predictive analytics model forecast market trends and manage risks. In healthcare, machine learning is used for diagnostics and personalized medicine. In generative AI, models like GPT-4 create new content such as text, images, and music. So these applications demonstrate the versatility and power of machine learning in solving complex problems. Next is challenges in machine learning. So despite its power, machine learning comes with challenges, issues such as overfitting, where a model performs well on training data but poorly on new data, and underfitting, where the model is too simple to capture the underlying patterns, can affect performance. Additionally, the data bias or the need for large data sets are ongoing challenges that require careful consideration. Addressing these challenges is crucial for developing effective and reliable machine learning models. Then recap of machine learning basics, what we learned. To recap, machine learning is a powerful tool that enables systems to learn from data and improve over time. It encompasses various types of algorithms, each suited to different tasks, with data playing a critical role in model success. Understanding these basics is essential as we delve deeper into the world of AI, like what we see, that training data, machine learning algorithm, then building logical mathematical mode and output, so learn from the data. So looking ahead, in our next lecture we will explore the key technologies in generative AI, including the neural networks and deep learning. So these technologies form the foundation of AI's ability to generate new content and will provide deeper insights into how AI systems operate. So do you have any question of the machine learning concept as we covered today? So you can ask any questions. So thank you, Joe, for joining me in this lecture on machine learning basics. I look forward to seeing you in the next session as we continue our understanding of AI and its transformative potential. See you there. Thanks, everyone.